In this video, we're going to discuss a project where we wanted to automate a locomotive, an HO scale locomotive on a Christmas tree train layout. And this locomotive has a DCC sound value decoder from SoundTraxx, but we want to power it with analog DC, but get some of the sound features that you get with that particular platform. And in particular, this is a small HO Christmas layout. It's about as small as you can make it. So we're going to start with this locomotive. I had this one sitting in a display. It's a nice little locomotive. It's from Bachmann with the sound value. Okay, in this particular decoder package, if you're running it on DC, it won't do anything until it gets up to about 5 volts, because remember that you have to have at least 5 volts or more at TTL, transistor logic level, in order for the decoder to start functioning. So it's not going to do anything until it gets to 5 volts or so. And at that point, you're going to hear some specific sounds when it's sitting there at above 5 volts. You're going to hear the background sounds such as the blower and the air pump. If it's a steam engine like this one, or if it's a diesel, you'll hear the exhaust. And if you increase the throttle further to, say, 7.5 volts or so, that will set the locomotive in motion. And when it sets it in motion at the kind of the threshold voltage is 7.5 volts, it's going along slowly and the bell is dinging. And when it takes off, it does a single toot or whatever the code calls for. And then it continues at that slow pace as long as it's 7.5 volts. And if you keep increasing the voltage, then at some point the bell will go away and it steadily goes faster and faster. It speeds up with the chuff from the steam engine synchronized with the wheel motion. Okay, if you want to change some of that, you can go, and if you have a DCC system, in other words, you have a controller and a cab or some way to work with DCC, you can go into control variable 197 and you can change some of that. And notice here that it's by default programmed to do 1 short toot when you come to stop, 2 medium toots when you go forward, and 3 short when you reverse. So when it's going to back up, it gives the most notable sound. Now in our application, I don't think I'm going to do anything in reverse, and you'll see why later, but that could be added. You can also add automatic grade crossing signal, but you have to go into control variable 197 on a DCC system to make that change. Don't worry about that for right now. You just got this plain little sound value locomotive, diesel or steam. Let's keep it simple. Okay, we're going to have a 36-inch diameter track. I picked that size because the Christmas tree is going to sit right in the middle, and it's probably going to be 4.5, 5 feet tall, which means it's got a stand with legs that stick out, and that gives you enough room at 36-inch diameter to add buildings and other decorations. Okay, so first we start with a locomotive that has sound functions, but we're going to run it on, but it will run on analog DC and still have sound functions. Even though it's a DCC decoder, it also produces some of these sound effects with DC. Okay, so you need some track, of course, to make a full circle, and then you need at least one piece of track that has the electrical connection. Now you could just take a regular piece of track, curved or straight, and solder some wires on it. I don't recommend that. Plus, I like a railer piece of track in every layout, at least one. That helps you get your cars lined up on the rails. And then we need a power pack. Remember, you're replacing the little variable power supply that has like a knob on it that allows you to increase, decrease speed, and reverse direction. And this is a 24 volt DC power pack that you can buy online for $12 to $15. It's 3 amps. You don't need that much current, but the higher the rating on the power supply, the less interference you're liable to get from ripple or lack of the capacitive filtering that's in the system. So don't worry about that. So this is a inexpensive power pack that you can buy online, $12, $15. And then we're going to need some circuits to take that 24 volts and to produce the other voltages, specific voltages that we need. So these are called DC to DC or buck converters. And these circuits, you put in 24 volts DC, and then you could get out anywhere from 1.5 up to about 24 volts. So you can adjust the little brass screw there on that blue potentiometer to get the voltage you want. Or this is the route that I went. Those ones on top there, $1.50 a piece. You buy 10 of them for $15. And down below, you get 5 of them for $15. So they're twice as expensive. But notice that they have a 3-digit display and they have screw terminals on them. So you don't have to do soldering if you don't want to. So you can just, put your wire in those screw terminals and crank them down. Okay, so let's look at the inexpensive one, the $1.50 one. The documentation online shows that brass screw, it shows clockwise boost, counterclockwise buck. Well, there is no boost. If you put in input, if you put in 10 volts, the output's going to be 1.5 to roughly 10 volts. You can't get any more out than what you put in. This does not increase the voltage higher than the input. We're going to put in 24, and we can get out anywhere from 1.5 to 24, or slightly less than 24. So really, clockwise boost, that should say clockwise voltage increase, clockwise voltage decrease. That's when you're actually bucking. So this bucking circuit bucks the 24 volts in and lowers it for something coming out. This is the $1.50 unit. Okay, so we're going to take 4 of these. Now, if you're using the more expensive version, the circuit's going to be the same. But the connections are slightly different, but they're named the same. Notice you got input minus plus, output minus plus. So we're going to start by hooking up the common, which is the black wire. Conventionally, black is minus DC or ground or common, and then red is positive. So we hook up all of the minuses because they're common. They all go to the low side of your power supply, the common or the 0 volts DC. And then we're going to hook up 24 volts DC to all 4 input pluses. We're supplying all 4 of these circuits with plus 24 volts DC. And then we're going to connect up output plus. We're going to use 4 different color wires, and we're going to adjust the potentiometers for roughly these 4 voltages. Now you're looking there and you're saying, well, there's 2 of them that are 7.5. And the reason that I have a 4th one, and I'll explain it in more detail later, is that as you're increasing the voltage and the locomotive's going faster, doing other features, if you decide to go back to a lower setting, there's a certain level of hysteresis that, in other words, if something happened when you went from 7.4 to 7.5, and then it started doing something, that doesn't mean if you go back to 7.4 that it's going to stop doing what it did. It won't. There's some hysteresis. You're going to have to go lower to a point lower than the threshold that got you up to that function. You're going to have to go to a lower value, and that little space in between those two is called hysteresis. Okay, I advise using 4 different color wires. You don't have to. The electrons flowing in the wire, they don't know what color the insulation is. That's all there for you. So all these wires could be black. They could all be red. They could be any color that you want. I advise using the colors red and black for 24 volts, and then 4 different colors, different than the red and the black, for your voltages that you're going to apply to the track. Okay, notice the dashed lines up there. This is not your whole circuit. So that plus 24 volts has to go to several other locations besides just these buck circuits. Okay, closer look at these buck circuits again. And the $1.51, that'll do the job. The only advantage of this other one over here is that you don't need a voltmeter on the output as you adjust it to see what it is. It just makes it easier. I would spend the money to get the ones with the display. It's only $1.50 more each. Now, if you got a space problem, if you're trying to pack this into a little HO building or whatever scale you're using, this will work for any gauge as long as it will give you as long as it'll give you sound functions when you're running it on analog DC. Something to note, the upper expensive one, the two of these have terminal blocks. The upper one has little solder pads next to the 4 in and out terminals. You can solder wires to those. The bottom one does not. The ones that I'm using is more like the upper one, but where you see those little rectangles of solder next to out plus, those are holes that go all the way through the circuit board, so you can actually put wires through there and solder it on the other side. So it's double-sided. I like the ones where you can solder the wires and then leave those terminals for something else. As long as you solder a wire to out plus, that's the same electrical connection as the terminal right next to it. Okay, controller or sequencer. We're going to use the smallest one that I could find, and that's this from Velocio. It's called the Ace 11. Now, I'm actually using a slightly different one, but you can see on the DIN rail that this thing is not very big. And you can buy a little snap-on connector, physical bracket that you can snap the Ace into, and then you can snap it right onto the DIN rail. That saves you drilling holes and mounting it with screws. Okay, the Ace 11 is what we're going to use in our discussion, but I'm actually using the 1430, which the only difference between the two is this one only has 6 in and 6 out, but it does have a USB programming port, even though it's not indicated in the picture. Whereas here, this not only has USB programming port, but it has a serial port configurable as RS-232 or 485 and Modbus RTU slate. Those of you that aren't into any of this electronics yet, you're just interested in the train aspect, don't get too hung up in remembering this stuff. And this one will do the job that you want. Don't spend the extra money if you don't have to. Now later on, you may wish you got this one because you came up with more things to do. But for right now, we're going to use one input for something to start the thing running, and then we're going to use 4 outputs to pick which one of those voltages we want on the track. Okay, so coming off of that Velocio Ace right there, you see the C, the D, and the E, those connectors? Well, here we have a connector that's going to another circuit board called a relay terminal board. And this one has ISO in the nomenclature because it has 6 dry contacts that are isolated. In other words, there's no connections in between R1 through R6 there on that relay board. And then you see cable from PLC that connects into one of those connectors, the output connector back here. So you see digital out down there, D, that connects the cable to PLC. Now you don't need to read through these specs, but you can also take the connectors that come with the Ace. Over there to your right, you see a black connector and it's got some different colored wires plugging into it. You just strip the wires and slide them in there. Now, I use strictly stranded tinned wire, 22 gauge, for almost everything I do in all of my training stuff. That's sufficient. You don't need larger conductor because it's just milliamps, thousandths of an amp. So you can wire up your own connections. You don't have to use this relay board, but it's a good idea. Okay, So that's one relay board. This is the one we're using. Notice the 6 dry contacts, R1 through R6. They're isolated. In this relay board, they're not isolated. You have 2 groups of 3. So you have a common conductor. This will work for our project, okay? You don't need the isolation, because what we're going to do is the common will be going to the track, and then we'll be feeding in different voltages to R1 through R6. So all of them are focused into the track. Now, the value of the isolated is, if you only use 4 of these relays to switch power to your track, and you want to use the other 2 for something else, you may have a problem if they're not isolated electrically. Okay, so here's what you got. Notice the 4 colored wires down there on both diagrams. I mean, the bottom one is a diagram, the upper one is a photo, but both of them are the same circuit, except the upper one I show the red and the black going to 24 volts in. And then I extend the black over to one rail of the track. So coming from the buck voltage converters, orange, blue, gray, and green, was 7.5, I don't know, 10.5, 11, and 7.5, whatever it was. When those relays are energized, it's going to put those voltages on the blue wire going to the track. And the other rail of the track goes to the black wire. So there's your DC. So instead of having 1 voltage fed to the track, we're picking between 4 voltages from the buck converters.